All right, 4.2, solving multiple step equations. So what you're going to see here is similar to the last example that I did in the last note. That is, to solve an equation with more than one term, collect like terms with the variable on one side and the constant like terms on the other side. Okay, so an example of this is the following. 3x plus 2 is equal to 2x minus 4. 7 minus 2k is equal to 8 minus 5k. 5 minus 3n is equal to 3m is equal to negative 2 minus 2m. So let's look at the examples here and look at how we can solve it. That is, for this, what we want to do is be able to move all the x's to one side and all the y's to the other. That is, we need to move the x's to the side to make the x positive. So what we'll do, if you're not sure which side to move it to, the way to do it is to move everything to the letters to the left and numbers to the right. So again, 3x and 2x, we're going to move 3x and we're going to move the 2x to become minus 2x on the left side of the equal sign. On the right side, we have minus 4, and then we're going to move over plus 2, so we have minus 4 minus 2. That is, 3x minus 2x gives us x on this side equals negative 4 minus 2 gives us negative 6. So we found out that the solution to this equation is x equals negative 6. Let's look at another example. That is, 7 minus 2k is equal to 8 minus 5k. So we have the minus 2k here already. And what we're going to move over is the minus 5k. So that becomes plus 5k. So again, the minus 5k moved to here and it turned to plus 5k. We already have 8 on the right-hand side, and we're going to move the 7 over here. To move the 7, we need to know that this is plus 7. So we move it over, it becomes minus 7. So what we have here is negative 2k plus 5k is 3k is equal to 8 minus 7, which is 1. That is, 3k is equal to 1. That means that k is equal to, that's right, we divide 1/3. And we leave that in fraction form, folks. Simplified with no decimals and no mixed fractions. So fraction form, that is proper or improper fraction, no mixed fractions, and definitely, folks, no decimals, because your answer is then wrong. All right, looking at the next example. We want to put the m's to the side where it will be positive. Well, folks, this time I'm going to put my m's onto the right side. That is minus 2m plus 3m. The reason why is when I move the minus 3m over here, it'll turn into a positive. If you can't see which side is going to go positive or negative, the theory of you will go back to the theory where I told you, where letters left, numbers right, and you won't go wrong. This is just showing another way where sometimes the letters can go on the right-hand side. But don't worry, if you stick to the letters left, numbers right, you should be good. All right, so negative 2m plus 3m is on the right side. On the left side, you will have 5 plus 2. All right, simplify it even further. Minus 2 plus 3m is going to give you m, and 5 plus 2 is going to give you 7. Now, folks, if I wanted to check, I would plug in m for 7 and see if my left side is equal to the right side. And we'll see an example on the next page. Another way to do it, like remember earlier I talked to you about letters left, numbers right. This time I'm going to show you where the letters are on the left and the numbers are on the right. So letters left, you get negative 3m plus 2m is equal to negative 2 minus 5. That is letters left, numbers right. And negative 3m plus 2m is going to give you negative m equals negative 7. Now we're not done, folks, because we need to get m by itself. You have negative m is equal to negative 7. That means that m is equal to positive 7. That's right, positive 7, folks. So m is equal to positive 7. And that's the final answer. And look, whether it's in red or in blue, you get the exact same answer. Cool, isn't it? All right, moving on. 5y minus 3 minus y minus 2 is equal to 19. And then E is letter here, and F is over here. Okay, we're going to do the last example with a check, folks. So I'm going to show you what a check is with the last example. But let's look at these examples here. 5 bracket y minus 3 minus bracket y minus 2, close bracket, equals 19. What we need to do is expand this left side. Expand and simplify the left side, and then we can move things over. So leave the 19 where it is. That is, we expand 5 times y and 5 times negative 3, which is minus 15. And then we have the negative over here, folks, gets multiplied into here and here. Now, how come the 5 didn't multiply over here? Well, once the bracket ends, so does multiplying the 5 out. So once the bracket ends, so does distributing the 5. So 5y minus 15, and then we have minus y plus 2, and that equals 19. Now, I'm going to leave my y's on the left side and move all the numbers to the right side. So we have 19, and then we have plus 15, and then we have minus 2. So 5y minus y is 4y. 19 plus 15 minus 2 is equal to 32. We divide both sides by 4, and we end up with y is equal to 8. Now, if we wanted to check our answer, you can always multiply it into here. 8 minus 3 is 5. 5 times 5 is 15. 8 minus 2 is 6, so that would be 6 here. 15 minus, 5 times 5, 25 minus 6, 25 minus 6, that will give us 19. So I'm going to show you a check in the last example, so you can do a check for any question. All right, 2 times x minus 3 is equal to negative 3 times x minus 5 minus 6. What we want to do here, folks, is we want to expand first. So multiply the 2 and then multiply the 3 out, and that 3 does not get multiplied to the negative 6. This is really important to note. The negative 3 does not get multiplied over here because the bracket ended. So we end up with negative 3x minus 15 minus 6. And now what we're going to do is move the letters to the left, the numbers to the right. That is 2x plus 3x is equal to negative 15 minus 6 and then plus 6. That's right, this minus 6 moved to the other side. It became plus 6. So 2x plus 3x is 5x. And then the other side is just going to be negative 15. So 5x is equal to negative 15. And now we want to divide both sides by 5, and we get x is equal to negative 3. Okay, the last one. What we're going to do with this last one is we're actually going to solve and check this last one, just so that you have some experience with solving and checking your answer. I've talked a lot about it, but we haven't done a formal check. So we're going to do a solve and check in this last example. So here what we have is 2x minus 3 times x plus 5 is equal to x minus 1 times 2x minus 7. Let's expand this out. 2x times x is 2x squared. 2x times plus 5 is plus 10x. Minus 3 times x is minus 3x. And minus 3 times 5 is minus 15. Is equal to x times 2x, which is 2x squared. X times minus 7 is minus 7x. And then minus 2x, and then the last one, folks, is plus 7. So we've expanded it out, and now we're going to move things over. So letters left, numbers right. We have 2x squared minus 2x squared, and then we have 10x plus 10x minus 3x plus 7x plus 2x. So that's all the letters on the left side. So again, 2x squared minus 2x squared, plus 10x minus 3x, so we have the plus 10x minus 3x, And then these two over here are going to move to the other side, and we get plus 7x plus 2x. And then we're left with on an equal sign, and on the other side of the equal sign we have plus 7, which is originally there. The plus 7 is over here, and then we're going to add 15. All right, so we're going to expand this out. Look at this. 2x squared minus 2x squared gives us 0. All the x squareds are gone. And then we have 10x minus 3x plus 7x plus 2x, and then we have 7 plus 15. 7 plus 15 is 22. The 2x squared minus the 2x squared is gone, and we're going to be left with combining the like terms with the x's. That is 10x minus 3x plus 7x plus 2x, and that will give us, that's right folks, 16x. Now, what do we do now? We always divide by the number next to the x. That is, divide both sides by 16. And we end up with an answer like x equals 11 over 8. Now, a lot of you are probably going, oh no, fraction, it can't be right. Yes, it is, folks. And we're going to show an example of how to check this. So, one more time, we're going to show how to check it on to the next page. Okay? Just hold on a minute, we'll get to the next page. Okay, so what we have here, and let's look at the previous page. This was our last question that we dealt with. This was the question, and this was the answer. So what I'm going to put on the next page is the original question, there it is in black, and the answer. So essentially how do we check is that we check this answer in the original question. So we check x equals 11 over 8 into the original question. Now how do we do a check? All right. So a lot of teachers do checks a little differently. This is basically how I'm going to say it. Is you rewrite the question, folks. The left side of the equal sign was 2x minus 3 and x plus 5. That was the left side of the equal sign. So we'll call it left side. And then we had a right side of the equal sign. The right side was x minus 1 times 2x minus 5. That was our right side. What we want to do now is split a line down the middle, okay? And instead of an equal sign, we're going to check to see if these are equal. So essentially, we're creating a left side and a right side. We're checking to see if the left side is the same as the right side. Now, we no longer have an x anymore. What is our x value? Well, our x value, folks, is 11 over 8. So instead of x, I'm going to rewrite x as 11 over 8. So 2 times 11 over 8 minus 3 times 11 over 8 plus 5. So every time there's an x, I replace that x with 11 over 8. And I do that also on the right-hand side. So again, 11 over 8 is replaced for x minus 1. And 2 times, instead of x, again, we write 11 over 8 minus 7. What we're going to do now is simplify both sides. So you take your calculators if you need to and calculate that first set of brackets, which will be 11 over 4 minus 3, which will be negative 1 over 4. And that's the answer for the first part. And the second part is going to be 11 over 8 plus 5, which is going to be 11 over 8 plus 5 is 51 over 8. All right, and our final answer is going to be negative 51 over 32. And that's the left side. Now the right side, let's check our answers here. 11 over 8 minus 1 is going to be 8 over 8, which is, 11 over 8 minus 1, which is 3 over 8. And that is our x minus 1. That'll be 3 over 8. And the other side is going to be 2 times 11 over 8 minus 7, which is going to be 11 over 4 minus 7, which is 11 minus 28, which is negative 17 over 4. All right, so 11. So we have this now. When we multiply this 3 over 8 times negative 17 over 4, we will get negative 51 over 32. Now, do you see what I see? Oh, I hope you do. Look at both of these answers. That's right, folks. The left side is equal to the right side. That is, left side is equal to the right side. We have checked, folks, that it's equal. And what has that made us? Well, that's made us happy. One more time. We have checked that it's equal, and that has made us very happy that we've checked our answer. So in order for our answer to be true, the left side has to equal the right side. All right, folks. Well, that's the end of the lesson. Have a numerical day.